In this video, I am going to explain you the dispersion in the optical fiber. So when the light ray passes from the optical fiber, the core of the optical fiber, and at the output end, if we are getting the light signal spreaded, then that is known as a dispersion. Suppose that I am passing this signal, and at the output end, I am getting like this. Then this is known as a dispersion. So the basic definition of the dispersion is when the ray of the light or the signal passes from the core of the optical fiber, this is the core, passes from the core of the optical fiber, and at the output end the signal gets spreaded, then that is known as a dispersion. Dispersion limits the light signal carrying capacity of the optical fiber. There are the two types of the dispersion. First is intramodal dispersion and second is intermodal dispersion. In intramodal dispersion, we have two subtypes: material dispersion, waveguide dispersion. Intramodal dispersion is also known as a chromatic dispersion, and it occurs in the fiber, single mode optical fiber. So in intramodal dispersion, basically what happens is that light signals which have the different wavelength, when propagated through the core of the optical fiber cable, then the spreading of the signals happened, and this is known as a intramodal dispersion. Suppose that the light signal is propagating through the core of the optical fiber cable, and this signal have the different wavelengths. So because of this, different wavelengths have different speed when they are propagating inside the core of the optical fiber, and they will arrive at the different timing interval, at the output side. So due to that, the broadening of the light pulse happen, and this is known as a intramodal dispersion. So in intramodal dispersion, material dispersion is present. So in material dispersion, basically what happens is that uh, when the fiber optic get manufactured, assigned with a fixed refractive index, but due to some manufacturing error, variation in the refractive index of the core happens. This is the core, and in this variation, this is the core, and in this variation in the refractive index happen, then the dispersion which is causes by this is known as a material dispersion. So when I will pass the light signal from here, and suppose that it have a certain wavelength, light signal have a certain wavelength, so what will happen is that refractive index is inversely proportional to the speed of the pulse, or you can say that the group velocity, speed of the pulse. So this is very important point: refractive index is inversely proportional to the speed of pulse. Refractive index is inversely proportional to the speed of the pulse. So if the light signal is passes from the core of the optical fiber, and if there is a variation in the refractive index, then what will happen is that uh, change in the velocity, or you can say that the speed of the signal happens, and that result into the dispersion, and this is known as a material dispersion. So suppose that I am passing this signal, and it come out, and suppose the signal was like this, and at the output end it is like this, then this dispersion is caused by the variation in the refractive index, caused during the manufacturing process, and this result into the spreading of this light signal, and this is known as a material dispersion. The second is the waveguide dispersion. It also comes in the uh, intramodal dispersion, and important point is that material dispersion and waveguide dispersion, these two occur in only in the single mode fibers. So in waveguide dispersion, what happens is that when the ray of the light uh, passes from the core of the optical fiber, so what happens is that the basic concept to propagate the light signal from the core of the optical fiber is total internal reflection. But in waveguide dispersion, what happens is that some part of the light get propagated through the cladding part, through the cladding part. Some part of the light signal get propagated through the cladding part, and the speed of the light signal which is propagating through the cladding part is higher as compared to the light signal which is propagating into the core part. Suppose that I am suppose that light signal is passing like this in the core, and in cladding part suppose this is like this, and the speed of this light signal is greater as compared to the speed of the light signal in the core part. So what will happen is that the light signal which is propagating through the cladding part will arrive earlier as compared to the light which is propagating through the core part. So due to this uh, dispersion happens, due to this spreading of the signal happens, and this is known as a waveguide dispersion. The second type of dispersion is called the intermodal dispersion. Intermodal dispersion is seen in the multimode fibers. So suppose that this is the axis of the fiber optic cable, and uh, as you all know that in multimode fiber there are the different modes through which the laser signal can propagate in the fiber optic cable. So uh, when light signal 1 passes from this propagates from this fiber optic cable, and let me change the color for the second light signal. Suppose this is the second signal. Okay, as you can see here, this is the second light signal and this is the first light signal. So what happened here is that uh, the time taken by the light signal 1 is greater during the propagation as compared to the time taken by the light signal 2. This happened because both the light signal have different wavelengths, and due to which the speed of the light signal varies. So because of this, they will arrive at the different time interval, and this lead to the spreading of the light signal, and this is known as a intermodal dispersion.